more items, say now you have 3, then each of the inputs can be converted into a signature, and then you can union, and finally count the distinct count, and it's probably give you a number 3. And since each of the union operations can be processed in parallel, so basically you can build up a union tree, and the complexity of this algorithm will be just O log n. So it's like each of the union, it's basically like a log n length of height of the tree. And if you work on this algorithm using MapReduce, when the data size is so small, that's only a few hundred kilobytes, MapReduce automatically gives you an optimization that's it will put it into memory when it is so small that it doesn't have to spill into disk. So when you compute this hyperlog blocks using MapReduce, it doesn't need to spill into disk at all. Everything is in memory computing by default. So it's like a lot of people criticize that Hadoop can only do like spill into this computation, and hence it is slow. But when you use a better algorithm, your MapReduce just convert it into in-memory computing just for free. And here I actually have a program that shows like the error rate over 10 billion distinct elements. And let's try to pull it out. Precision visualization. Where is it? I can try. Resize the window first. So it's like from 100 million to like 10 billion. The precision is around like, in maximum it's about like 0.78%. This is like even below 1%.
对，问一下，你这边的话，那个你的总数，因为 hyperlog 要设那个 bitmap 的 size 嘛，就是你要根据你的 error rate 去设那个 bitmap size， 那你这个是设多少？那你那个 bitmap 大概多大
？The bitmap size, as I could recall, I set it to 14 bins plus 5. I can't remember the other counts, but there's a combination of the bin size and another count. I remember it's around like 13 and with probably 5, but I can't remember what is the second parameter. Yeah. And also the size for this one, I remember it was about like 500 kilobytes per each hyperlog block estimate. Next slide. Oh yeah, and also it has a very fast computation rate. It was like calculated in 30 minutes. It's like 10 billion elements, distinct counts. It doesn't even use MapReduce. I just calculated linearly, and the runtime is actually very fast. So let's see what kind of application we can use with hyperlog block. So one particular use case is trying to see the unique user count per hour. So it's like within each hour, you just generate a hyperlog block signature and then store it. If you want to see like the 4-day unique user count, you just combine all of those using a union operation, and then you can just get the distinct counts of all the users in this one day. And so every time you want to count distinct, you don't have to recompute all the daily data. You just need to compute each hour's hyperlog block, and then finally get the daily estimate. Is like very cheap. And also when you can calculate the union, you can get the intersection. Now you know the count distinct elements for estimate for A, and you know the distinct number for B, and you know the union of A and B, then you can get the intersection. So here is a demo that I wrote for checking intersection. And where did my browser go? Here. So basically, each of the bar here is like hourly data, but it's a white noise data that I generated. I couldn't use like our company data for demo, but I can select the data I want to check the intersection with the other hours. So if I select these 3 hours, I can tell that some of the unique users here show up on the next hour, because that's how I generated my data. Yeah, and also I generated some white noise that's it's just like the lowest bar here, and it's just for demonstrating that if some of the unique users show up like 24 hours all the time, then it's probably a web bot. Yeah, and you can see that all of those union intersection computation is like real time, so it's like very smooth. And traditionally, if you want to do this kind of visualization, it's like it will be too expensive to compute and also hard to visualize. But now, using a probabilistic data structure, you can compute it just like in browser on the fly. Yeah, this is, if my demo didn't work, I have something to say about. Yeah, and yes, I was also trying to combine my demo with a JavaScript called DCJS. It can do dimensional charting, but I didn't have time to do it, and I didn't continue to do the development here. Yeah. So put those things together. What can you tell for the business value for that demo I just demonstrated? For example, you can calculate the churn rate. That is whether a customer returned back to your website. Did it increase or decrease after a particular release? And also, it can help you to find good or bad patterns, user bad patterns. I was just demonstrating like a very, very simple pattern that I generated manually. But if you are working on it using a real-world data, you can probably see some more patterns that you couldn't see in the demo. And this is also a new way to define healthiness of your web applications, because it can help you to visualize some of the user behavior that was very hard to visualize before. And none of those visualizations were possible because of the memory footprint. Storing a very, very large set operations, set data structure was very, very expensive. But now using probabilistic data structure to store a set becomes so cheap that you can just compute it in the browser. And yeah, actually I also wrote a Hive demo, Hive code, but let me see. Yeah, here I was just trying to, this is a very, very bad demo here. But, well, Hive have a function that you can generate each of the hourly data and insert it into a different partition using this syntax. So I can generate like partition for the 0th hour, the 1st hour, and then it will generate the hyperlog signature into those partitions. And finally, I can combine all of those hyperlog hash. It's just like those signatures, and then estimate the full cardinality. Yeah, it's basically some of the open source pet project that I created. Yeah. So I also have an explanation of the algorithm that can do this magic. But I found that when I start to explain this, people just play sound. Like maybe people here in our group would be better. Maybe. I know a lot of people here has mathematical background. It's been 4 months ago. I hope I can still recall how it works. So, say we have n elements. That is the 4 sets of the elements I want to insert it into the this hyperlog data structure, and I have actually m number of distinct ones. So, let me see. Actually, can't recall that much of I probably need some time to recall how do I calculate this. Maybe if I explain it in Chinese, I can explain it a little bit better. But say I have a hash function that map one of the elements into a 0-1 combination of the hash. And then I define a function called RA. This is the A is an element that that I'm trying to calculate the hyperlog like the number. And R is basically if I have the 1 on the second in the second part of my hash binary string, then it returns a number of 2. And the probability of RA equals to 2 is 1/4. So far, is this like okay to everyone? It's pretty much like if I like every 0 and 1 probability either turns on or off, the probability is 2, right? Like 1/2. And if I have like first element is 0 and then the second element is 1, and I don't care about the rest, having 0-1 combination, the probability will be 1/4. Yeah. And if I have like 0-0-0-1, then the probability will be 1/16 because I have like three zeros following a 1. Then it's 1/16. So